Hello everyone. Today we will see a 8051 program to find whether the given number is even or odd. So here the number will be stored at 30H memory location. That is the number which we want to find whether it is a even or odd. That number will be stored in 30H memory location, and the output will be AAH if the given number is even, and it will be stored at 50H, and the output will be BBH if the given number is odd, and that will be also stored at 50H. Now, why we are using the representation as AAH and BBH? You can use any representation. Here I have used AA and BB. You can use CCDD. It's your choice. But why we are using this representation? As 8051 assembler, it cannot display messages, so we are using the representation for even and odd numbers. Now, first we will determine, or first we will get to know how to decide the given number is odd or even. So, we will consider a 4-bit number with their positional weights, that is 8421. Now, here 0 is represented by 000, 1 is represented by this, similarly up to 7, and you have again from 8 to 15. So these are the 8421 positional weights. Now if we carefully observe the even numbers, that is, suppose you have 0, 2, 4, 6. If you see these numbers, the least significant bit, here it is 0. 2's least significant is 0. Similarly, 4's is also 0. 6 least significant is 0. And here also you can see for 8, 10, 12 and 14. Similarly, if we observe the LSB of odd numbers, that is 1, 3, 5, 7, 9 and so on up to 15, you can see the LSB of these odd numbers is 1. Okay, so if the LSB is 1, it means that the given number is odd, and if the LSB is 0, it means that the given number is even. Okay, so this is how we find whether the given number is even or odd. Now let us consider a 8-bit number, okay, which is stored at the memory location 30H. So here it is A5. So the number has LSB and it has MSB, but our interest is in finding the least significant bit, because it will decide whether the given number is even or odd. If the LSB is 1, okay, that is, if the LSB is 1, it will be a odd, and if the LSB is 0, it indicates that the given number is even. Now here first we will see what is this rotate right through carry instruction, because we are using that in our program. So here we have a 8-bit number and we will rotate this or the bits present in this 8-bit number towards the right with carry. That is, whatever the bit is there in the LSB, it will come into the carry flag, and the carry flag bit will go in the MSB. So the new MSB will be the carry bit. Okay, so this is your rotate right through carry, and this will work on the accumulator, because of which here we have taken it as RRCA. So here you have 8-bit number, we are rotating this. So here we are using the instruction rotate right through carry. So the LSB will go into the carry bit, and the carry bit will be transferred or moved to the MSB. So the new MSB will be the carry flag bit. Okay, so if CY, that is the carry flag is, that is the carry bit is 1, the number is odd, and if the carry bit is 0, the number is even. Now we will see the program. Here we will start with the directive ORG 0000H. Now Here we want to find out whether the given number is even or odd. So we have taken the number, that is we have taken this number, that is 10100101. So here we have seen that here the least significant bit is 1. It means that the given number is odd. So we have to store in the result at 50H, it should be stored as BBH. Okay. So this is the logic of the program. If it is 0, if the least significant bit is 0, then at 50H memory location, that is at the output, we have to get AAH. If it is even, we have to get it as AAH, and if it is odd, we have to get it as BBH. So now we will see the program. Okay, this was the instruction. Now we will begin with what? We'll begin with the directive org0000H. First, we will take the given number which is stored at 30H into the accumulator using the direct addressing mode. Now, we will copy the data which is stored in the accumulator, and the instruction used for this is move a, 30H. Here we can notice that when we do not put the hash, here we have not put any hash, it means that this number, that is 30H, it will be treated as an address, and the data stored at 30H will be fetched and it will be copied into the accumulator. Now once we have got the number into the accumulator, we have to check the LSB. To check the LSB, what we are using? We are using the rotate right through carry instruction, and it will like here all the bits of the given number will be shifted, or these are rotated one bit to the right, and the LSB enters into the carry bit and the carry bit enters into the MSB, and the rest of the bits, those are shifted one bit to the right. Okay, that is how the RRC works. Now our interest is to get the LSB bit into the carry bit so that later we can check the carry flag status and determine if the given number is even or odd. So we need to move the LSB into the carry bit, and the instruction used for this is the RRCA, that is rotate right through carry. Now the LSB is moved into the carry bit, so the carry flag will be either 0 or 1. If the carry flag, that is carry bit, is 0, it means that it is an even number, and for even number we need to store it as, or we are representing it as 0 AAH. So here hash 0 AAH, we cannot write directly AA, we have to prefix it with 0, because any number which begins with the alphabet, it must be prefixed with a 0 so that the microcontroller treats it as a number and not as the label. So here wherever AAH and BBH is there, I have prefixed that with 0 so that the so that the microcontroller, it does not treat it as a number. It must treat it as a number and not as the label. Okay. So here in the example we have used the LSB, that is the example which we have used A5. In that the LSB is 1 and the carry bit will be 1. It means that it is an odd number and we need to store BBH in the memory location 50H. So this checking whether the carry bit is 0 or 1, it is done by the JC instruction, that is jump if carry is equal to 1 or jump on carry. Now whenever the carry bit is 1, we jump to the specified label, that is loop 1. Okay. So what we should do at that specified label is, here in this case we need to store BBH at the memory location 50H. So at the label loop 1, we need to copy the data BBH into the memory location 50H. So we are using the instruction loop 1, that is the label, and the instruction is move 50h comma hash 0 bbh. Now if the carry is set, it jumps to the loop 1 and executes this statement. In case the given number is even, suppose the given number is A2, we have taken A2 instead of A5, so the LSB at that time it will be 0 and the carry will also be 0, so it should not jump to loop 1. Instead it should go immediately to the next instruction and it has to store AAH at the memory location 50H. So the instruction which does that is move 50H comma hash 0 AAH. So once we are done with this, the carry flag is checked. If it is 1, BB is stored at 50H. If it is not 1, AA is stored at 50H. So after storing AAH, it should not execute the loop 1 level, that is it should not go to loop 1 level, and here that is hash 0 BBH, it should come out of this line and it should come to the last line where we stop the execution, that is here colon jump here, that is it will enter a infinite loop and it will end the program. So after the move 50h comma hash 0 AAH, here we give a unconditional jump by using the S jump here. So the control comes automatically to what? It will come directly to this instruction, that is here colon S jump here. Okay, and it will not give the control to this, it will skip this instruction, that is it will skip this instruction loop 1 colon move 50h comma hash 0 bbh. So this is the logic of the program. What we are doing here, we are taking the number into the accumulator, we are rotating it towards the right with carry or through the carry, and we are using the jump with carry instruction, and the and if the carry bit is 1, then the control will be given to this instruction, and here the it means that the number is odd, so we'll get BB in the output, that is at 50h memory location. If the given number is even, then it will go to this move 50h comma hash 0 AAH instruction, because the carry bit will be 0. Now immediately after executing this instruction, it has to come out of the, or it should not execute this instruction directly, it has to come to this here colon S jump here. So we are using a unconditional jump by using the instruction S jump here. So this is the logic of the program. Now suppose here input we are giving at 30h memory location is A5, its output must be BB because it is a odd number. For odd number we are using the representation as BB. And if the input is A4, okay, A4, A2, A6, that is if the number is even, then output must be AA. Okay, sorry, here I have written wrong, it should be AA, that is here I will write it as AA. Here you'll get AA. Okay, if the number is odd, it must be represented as BB. If the number is even, it must be represented as AA. Now we will execute the program. I will copy the program from here. We'll go to the Keil software. Expand it or maximize it. Close this. We'll go to the project, new MuVision project. I will use the previously used project, or you can create your own new project. Click on yes. Search for 8089C51. You have got 8089C51. Click on OK and click on no. Now go to the file, new file, type your program. I'll directly paste my program here and save it. Okay, so it is even and odd, so I'll write it as E O dot ASM. Okay, you have to save it with dot ASM extension. So as soon as you save it, here the color of the mnemonics will be changed. Now go to the target, click on this plus symbol, you will get source group 1. Right click on this source group 1, you will get these all options. You have to click on add existing files to group source group 1. Now search for your program. We have given the name as eo.asm. Click on add and close. Okay, now see whether your program has been added to source group 1. Click on this symbol, so it has been added. Now go to the project and click on build target. So here you are getting 0 errors and 0 warnings. Now we'll go to the debug and click on start or stop debug session. Click on OK. So here at 30H memory location, we have to give our input I colon 30H. Okay, so and to see the output, we have to use the memory location, that is 50H. I'll select one more memory window from here. So memory 2. Memory 2 is what? It is I colon 50H. Okay. So at 30H, we will enter our number. I will give it as A5. Okay. Now it must represent it as what? BB, because it is a odd number. So we will check the output at memory 2, that is at 50H memory location. Go to debug and run. So you can see here you have got BB because it is a odd number. Okay. Now we will stop the execution, reset here. Okay. Now go to again 30H and change your input. We'll give it as A2 and we'll check the output at memory window 2, that is 50H. Go to debug and run. So you can see here you are getting AA because here we have given the even number. Okay, so when it is even number, it should display AA. When it is odd number, it should display BB. Remember one thing, you can use any notation to represent your whether the given number is even or odd. I have used here AA and BB. You can use any number of your choice. Okay, thank you.